Question 10. In this question, we are asked to study the pattern below. Each diagram is a different term. According to the table below, the term number is indicated by a letter T and is considered the input, and the number of mini-circles in each diagram, indicated by the letter M, is the output. Term 1 has 1 mini-circle. Term 2 has 4 mini-circles. Question A asks us to use the pattern to determine the values of A and B. Thus, term 3, number of mini-circles, can be counted. Thus, A is equal to 7. B can be calculated by counting the amount of mini-circles in term 5. B is thus equal to 13. Question A also asks us to determine the value of C, so we need to calculate the term number this time that has 16 mini-circles. To do this, we need to see some kind of pattern. Well, we can see that the number of mini-circles seem to go up by 3 from one diagram to the next. 1 plus 3 gives us 4. 4 plus 3 gives us 7. 7 plus 3 gives us 10, and 10 plus 3 gives us 13 mini-circles. This would then mean that the very next term would have 16 mini-circles. So C's value must be 6. Term 6 will have 16 mini-circles. Question B asks us to use our table to write down an equation in the form M is equal to ... We have already determined that the output values go up by a constant amount of 3 from one input to the next. So there is a constant increase of 3. This means that the relationship between the input and the output is one that is linear. The formula is easy to find. M, the number of mini-circles, is equal to this constant difference, 3, multiplied by the input, T. We still need to add or subtract a constant to make this formula true. To do this, we need to substitute any term number into T. Let's substitute T equals to 2, where we expect the output to be 4. In order for the output to be 4, 3 times 2 is 6. This means we still need to subtract 2. Thus, the formula for this equation is M is equal to 3T minus 2. This formula will be true for every term number. Let's try T equals to 4. 3 times 4 is 12. 12 minus 2 is 10. Question C. If there were 100 patterns in this sequence, starting with the one labelled 1 above, calculate how many mini-circles the 100th pattern would have. Show your working. This question is asking us to determine the number of mini-circles the 100th term will have. We do this by substituting into our determined formula from the previous question. M is equal to 3 times 100 minus 2. This gives us 300 minus 2, which is 298. So the 100th term will have 298 mini-circles. So now let's take a look at the problem-solving question, question 11. Lisa is making activity baskets for Mandela Day. She has 12 colouring books, 28 markers, and 36 crayons. Question A. What is the greatest number of baskets that she can make if each type of stationery is equally distributed among the baskets? This means that she wants to break or share these items into a certain number of unknown groups so that they are shared equally. Let's take a quick example. If we had 2 baskets, 2 is a factor of 12, 28, and 36. Therefore, we would have 6 coloring books going into each basket. We would have 14 markers going into each basket, and we would have 18 crayons going into each basket. This is all very well, but the question does stipulate what is the greatest number of baskets that she can have. So this means that we are going to work out the highest common factor. 2 is a common factor for 12, 28, and 36, but we would like the highest common factor. We want the greatest amount of baskets. So let's work out the highest common factor using the ladder method. We learned that to use the ladder method, we need to ask ourselves what is the smallest prime number that goes into each, and then to find the highest common factor for all 3. Let's start with 12. 2 goes into 12 6 times. 2 into 6, 3 times. 3 into 3, once. 2 goes into 28 14 times. 2 goes into 14 7 times. And 7 into 7, once. 2 goes into 36 18 times. 2 into 18, 9. 3 into 9, 3. And 3 into itself, once. So the numbers on the left-hand side of the ladder are the factors, or rather the prime factors, of 12, 28, and 36, respectively. We are looking for the highest common factor, which will determine the number of baskets that we need in this question. 2 squared, 2 squared, and 2 squared are all shared by 12, 28, and 36. This means that the highest common factor of 12, 28, and 36 is 4. This means that we will need 4 baskets to share the coloring books, markers, and crayons equally and into the greatest amount of baskets. In the next question, they ask how many of each supply will go into each of these baskets. So now we know there are 4 baskets. So 12 divided by 4 is 3. 28 divided by 4 is 7. And 36 divided by 4 is 9. This means that there will be 3 coloring books in each basket, 7 markers in each basket, and 9 crayons in each basket.